Hello, welcome to this video. My name is Martin and this is a map of the driving times to the closest hospitals. So basically it's an interpolation of how far is it from any point on the map to the closest hospital. So you see there are parts like nearby hospitals where you're going to take less than 20 minutes and other parts where you might have an hour or even more. And in this video I want to show you how to make this awesome map. We're going to use R, leaflet. We're going to use OSRM, which is to calculate the driving times from any point. And let's get started. So basically, let's save this. So basically I made a post, a little summary that I published on RPubs. And what you're looking at here is basically the video version of this. So if you're not interested in watching videos, just head over to the text, which I will link in the description. For this, what we're going to use is we're going to use hospital data of Switzerland. Okay, now let's go step by step as I wrote it here. So basically you can also do it in a ggmap or a ggplot map of the driving times, which is basically static. And for preparation we're going to use OSRM. OSRM is the open source routing machine based on OpenStreetMaps. It allows you to calculate the shortest path, normally driving time or driving path from point A to point B. So that's what we're going to use. And what you're going to use is you're going to use the OSRM package, which is available in R that I already have installed. And by default, okay, that's interesting. We already have it. By default, you don't have the local host. You have a router project OSRM, which is basically a public server for you to test the thing. If you're going to use if you're going to have a lot of requests, which we will need for having a random point interpolation, you're advised to have your own server running, which sounds more difficult than it is because there is a Docker image that you can get from Docker Hub, which is the OSRM backend, and you have to download the weights, which you can find from geofabric.de, and here you can find for I advise you against downloading the whole continent, just go because it's alone Europe is 19 gig. Go for one country that you're going to need. Switzerland, I think it's 290 megabyte. So that's what we have done. I have the data, I have Switzerland, and in my and basically to run the Docker image, it's well documented. So I just copied it, but it's also what you find on the OSRM backend, how to run, blah blah blah. So mine is Docker container list. You see mine is already up and running, so all is fine. If I didn't had, I saw that we already have the local host, else we would do it. We'll define it, local host, and get option, you have the local host. Let's do this a bit larger and zoom in, that's better. And we're gonna use, of course, some data. We're going to use the hospital data from Switzerland, which when I wrote up the thing on RPubs, we had the 2016 data. Now last week 2017 was published. So we're going to download this, which I already have in my data folder. I have my Excel sheet that we are going to read in. I'm using Excel read. for reading Excel. We have now 17. And we should check out the maximum number of rows. Let's open this quickly. Nothing. And that's, so the last row is just a summary of whole of Switzerland. We're not going to use this, but the total number of rows is 181. Sorry, 200. Yeah, 281. So 281. So a bit fewer than last year. So you're going to have these hospitals that we have in, like, the data that is provided by the Swiss government has various other fields that are of great interest. If you're doing other things like how many days do patients stay on average, or how many births did happen, but we're not necessarily requiring these at the moment. Okay, so now my video of me doesn't work anymore. Anyway, where were we? So we had imported the data. We see you have the hospitals. And next, what are we gonna do? This is not working. We're gonna select the emergency hospitals, because not all of the Swiss hospitals are for emergency service that fills my standards. So we need a emergency in acute medicine. NF stands for emergency in German, and CT is that we want one hospital is at least equipped with a computer tomography. Otherwise, it's, in my opinion, not an emergency. So this is what we're going to run, and you see you have 84 hospitals that offer emergency service. And now the next step is that we're going to use ggmap. So let's load the package at the beginning. I'm going to use ggmap to geocode. Now I already have them geocoded, emergency hospital geocoded. Let's load this, because I made another video on geocoding with over the Google API, but it does cost you a couple of cents per request. So I already have it geocoded from previously. So that's what we're gonna use. Emergency hospitals geocoded. And what do we have? And if this, we're gonna select. We're gonna select the institution, the address, the city, ward, the longitude, that's fine, and latitude. And first we're gonna have the emergency hospitals of 2017, and we're gonna left join this with what we already have. And no, it's because ggmap has some is interfering with the select of deployer and deployer, and now it will work exactly. And you see that not all of them have coordinates. It's because in the previous data set they wouldn't have coordinates, or they wouldn't be classified as emergency hospitals, so I haven't geocoded them just yet. So we're gonna filter for the non of longitude. That's not working today, and we're gonna save these as missing geocode, and only the missing geocode geocode. We're gonna create a new field address, and of this we're not gonna read in register. See if it's this. And then this is not displayed at all, and that's missing geocode address. So let's run this, and you see you got the 5 that were missing geocodes is now geocoded. 84 columns, that's, or 84 rows, that's correct. So that's our new emergency hospitals. We geocoded them. Next, as I say, it's advisable to save them, because next time you don't want to run Google geocoding again. Just save it for this reason, and we're gonna save this as 2017. Got it here. And next we're gonna load the leaflet. And we're gonna make a basic map. I have now, let's call this leaflet. We know where we are. So I have icons of hospitals that I put in my data folder that I'm gonna use here for the leaflet map. We have basic tiles that we're gonna use CartoDB. We can also use OpenStreetMap or any other tile that you wish, and we're just gonna plot the geocoded hospitals with the icon. So let's do this and have a preview. So here it is. That's the basic map that we're gonna build on from now on. Now for a driving time surface, we want to request random dots. So the idea behind this is we're going to request random dots on a map and request for these random dots the driving time to all hospitals. And then of course take the one that has the shortest time. Latitude, so basically here and here, maybe we want them in the range. And we're going to use, we say, that's the one today. And we're going to use 100 points for the moment, and we put random points and just generate random locations within this range. So you see you have like idea plus longitude and latitude, and we can plot them. Where are these anyway? Yeah, they're all over the place. And for each of these points now, we're gonna make requests to our own OSRM server using OSRM table. Let's use all of this. Random points, blah blah blah. Random points. Oh yes, we have to have them as a data frame, not a table that we did first. We have the hospital. What do we do here? Where's the hospital? Yeah, so these are the destination. So the source where you leave from is the random points. You go to all of the hospitals that we also need as data frame. And we just have the driving time. Let's have this. Oh, yeah, so this is for, so let's see, you have now 100 locations for all of our 84 hospitals. How long does it take? Takes a couple of seconds, not even a second, for 100 points. So 100 times 84, 8,400 routes. It just calculated in the background. It took less than a second times summary. Oh yeah, so basically you have always a source, a destination, and the duration. And out of these durations, of course, we want to have the smallest. We're going to use the driving time, and we're going to use the minimum of each row. We're going to convert it back to tibble. We're going to make a new string, and that we can plot and say, hey, this is the pop-up. That is just the character of the min time, and we're going to save this as the min distance. That's what we do now. We use a legend colors of the minimal driving times, and we add the basic map that we already have. We're going to add the marker points, that is the minimal distance that we just have, and we also can control, have a layer control, which is this thing you can control. And you see you have these points that we previously had as just points, and we have the driving time. So from here to the nearest hospital, it's just here, but it's like mountain roads. It's gonna take you 63 minutes. Whereas if you live in Zurich, well, there's nothing in Zurich. No random point was chosen for Zurich, but nearby Zurich. Say you're gonna live here, near the German border. It's gonna take you a bit less than half an hour to reach to the Schaffhausen hospital. And now what we're gonna do is not gonna do this for 100 points, but we're gonna use it for 10,000 points. So we run all of this just because 10,000 random points. Let's use this. We don't need really the seed, but who cares? And we have it in a for loop that we're gonna just run now. And of course it takes, you see, per request of 100, it's gonna take a bit less than a second as previous. The next step after this is done is to calculate again the minimum distance that we're gonna do. Here we're gonna see that there will be less minimum distances than the previous 10,000 points. Is because as you've seen here, all points that we previously had outside of Switzerland, because we only downloaded the data for Switzerland, all points, for example, if we had a random point here, it will be put here. So we're going to set calculate the minimum distances, have them distinct. And how many are there now? Yeah, 550, and save them again as mini distance, because why not? And let's plot these or add these to the map, and to map again with some colors. And you see already that you have this a lot of 5,000 points with the hospitals. Now we don't have the hospitals, but we know more or less. So let's say zoom into Basel, where they have a bit of opacity. Let's put 80 opacity. Yeah, that's better. So let's click on this random point. Oh, it's only going to take you 11 minutes from here. We want to have interpolation. So this is what we're going to use the SP and the raster package for. So let's load these two guys. I got them. And we say it's a interpolation. Oh, I was going to use SF and gstat. That's here. Which we all have. So I made this function to calculate. What we're going to use is we're going to define the grid resolution. So lower grid resolution will be mean that the individual grid, the individual pixels are smaller on the original map. But I found 500 is a good compromise. We're going to input the data, and we have some computation on have to change the coordinate system, and what it will use is a nearest neighbor interpolation. Yeah, so let's use this function. If you're interested, just look at the code. Done. Now again, did we save it? We should. Saving is always good. And again, we're gonna use the, oh yes, so basically the raster that we have, we can also plot. So if we plot this, you're gonna see this is the whole thing, but of course Switzerland has some shape, the country borders. So we're gonna use from GADM, from that you can download, what is it? This function is from the raster package. You can just download, you can define the country code, define Switzerland. It downloads it from whatever source we have. There you see the shape, and we're gonna shape it with the mask also from the raster package according to the borders of Switzerland. So if you have this, we plot it, you're gonna see it has now the proper shape that we want. Final map. Have the colors defined and make our map, and you see that again you have parts where it's going to take you forever to reach the nearest hospital, and parts where it's actually very close, of course, nearby actual hospitals. And we could have added a legend. Let's add this also to the final map. Yeah, that's not nice. This don't want. And yeah, here you have it with the driving times larger. And here you go. Also in my write-up, I tell you how to make it as a ggmap, static map, which is not very hard. We're going to use, we would also use maps to get a static map of Switzerland. So with ggmap, you cannot use the OpenStreetMap stuff. You're going to use maps, get the map, and basically plot it. Have a nice plot. So yeah, thanks for watching, and see you next time.